welcome to the last presentation on track 2 today. It's called OpenTelemetry featuring logs, metrics and traces, and presenting it will be Marcin Stożek.
Hello. Hi everyone, I'm Marcin. Everybody calls me Perk, but my mama gave me the name Marcin, and I'm not using that much. Not that it matters. I work for SumoLogic. SumoLogic is a vendor that takes your telemetry data and do very interesting things with that. With them, can create show you logs, metrics, and traces. And quite recently, we work a lot with OpenTelemetry because we believe that this is a very promising project. So let me talk to you about that, what it is, and why we think that it's worth to know about it. But first, I think that we need to start with this question: what is observability? Whether there is just a fancy word for monitoring, right? Because everybody knows this monitor thing. What is observability here? Here's the Wikipedia definition. Observability is a measure how well we can see how system operates, this internal system, this internal states, just by looking at the box, right? So box produces some telemetry data, and from this telemetry data, let's just infer some knowledge about the internal work. And when you think about it, you can actually say that this is not observability versus monitoring. To me personally, this is observability through monitoring. The way I think about it is that, for example, we create metrics, we create some logs, we gather this information, and we send them to the vendor. We see that on the Prometheus or Elasticsearch, and for me, this is monitoring. And observability starts when my monitoring is so good that, at the 2 a.m. when I'm woken up, my system doesn't work, I can take a look at those logs and metrics, and I can say, okay, so I have some information from this monitoring, but I need some other information. Do I have it? Like, I did not specify one metric, but maybe I can infer this information from something else. If I can, that is observability to me. Because I didn't know the question that I wanted to ask before. If I know the question, then it's monitoring. If I didn't know the question before the time, it's observability to me. And we have to ask this question: is observability a new concept? Let me ask you guys: what's your picks? Does anyone know or have an idea like what it could be? Nothing. It isn't, obviously, but how far it goes. It's 1960s. So observability is hardly a new concept, actually. It was originally introduced for linear dynamic systems, and I think that is still relevant. Okay, let's talk just a little bit about the signal types that we have. I think that this is pretty obvious to everyone. We have logs. We have metrics, traces, maybe not as trivial, but let me walk you through that. So for logs, hopefully I don't have to explain that to anyone. Logs, like everyone has created a hello world application in their life, probably. So then you get logs, right? Those logs have just a little bit of a problem when you run them on Kubernetes, for example. Because on Kubernetes you get logs from many instances of the same application, right? And now you have to have the additional metadata, because if you don't have this metadata, you just have a stream of information from your whole cluster, and it's just not usable at all, right? So logs are cool, but we need something more. What about metrics? Metrics are pretty good because they can show us how our application was actually performing, like a week ago, like 2 weeks ago, a month ago. Do we have any interval, for example? We know that, every Friday we have this surge in new requests. We have to have more servers, or we can have less servers, right? So this is very useful. And what about traces? Traces is something that is not that much used, I think, but it should, if you ask me, because traces are very helpful thing. And this is not a very new concept as well, because if you were in the Java world and you wanted to pass information from one service to another service, for example, and using like HTTP connections, you could correlate your calls with correlation ID. So this application called this application, and this application called another application. So I had this correlation ID that showed me that user action created this chain of things in my system. And also we had this request ID, which was exactly which service called which service, right? So those two, let's just switch them. We have trace instead of correlation ID, and we have span in place of a request ID, and that's actually traces. But let me go just a little bit deeper so that it's obvious for everyone. So let's imagine we have a client, and this client calls our service A. They don't need to know that this is service A, but they do. Then service A calls service B, and service B calls some database. So what is a trace? First of all, trace consists of spans, and this little box is a span. And the span has trace ID here, and it has the span ID. And the span ID will be different for every span, obviously, and the trace will be the same. So here, someone called our service A, and we, as a service A, we create a span. Somebody called me. So I answered. I requested. I provided a result that is okay. I got this HTTP GET. All the useful information that I could have here. But then my service A says, okay, I need some information from service B. So we have another span. So this is a second span. And the second span has the same trace ID, but those spans have obviously different ID. This different ID and this ID is different. And they are connected to each other because this parent span ID is the same, like here, right? So this is how they are linked together. And then, service B got information from service A. This trace ID and the span ID went most probably in a header or something. So service B knows about this context, so to speak. And thus the trace ID is the same and the parent span ID is the same. And obviously we have another span ID. And then we have this, DB call. This is just another span. And all of those spans, those 4 spans, they create a trace. And you can see it like that. Here we have spans, 4 spans, and this is one trace. And why this is interesting? Because for those spans we have information. What was the timeline? How much it took? So here we see that okay, service A called another service A, so that was easy, right? Then it called service B, but it was almost instant. That was okay as well. And here we had this DB call, and this took like a long time. Maybe our query was not ideal, or maybe it just needed to get like a lot of other data. We don't know. Maybe we can do something with this DB call so that it is faster, or maybe we see something like that. What happened here? Our service B either waited for something. We don't know. Maybe it was initializing this DB call, or maybe we have some part of the system that do not create trace spans. And hence we don't have visibility into those actions. It could be something like that. Either way, to me, it's very, very interesting thing. And this is very good here to have this information. See being provided like this view, because now we can ask, okay, so maybe my logs or my metrics can help me with that, right? But like I said before, for logs and metrics to help you with that, you need to have some metadata as well. And this consistent metadata is very, very helpful if you have consistent metadata across logs, spans, and metrics. And here we have example for the OpenTelemetry, OpenTelemetry metadata. When you use those and you have consistent metadata, so you know that, for example, you always have this metadata called application, and this application will be this string, then you can say, okay, I'm going from this span or this trace, now show me all the logs for this trace. And we can see it here. For example, this is a view, and on the under as red we have the errors here. So I can open my view, that is related here, open logs that are tagged with this trace ID. And when I do that, I see logs that are not just logs from this application from this time. Those are logs that were, you know, exactly resulting in an error. And this is pretty powerful because, you know, I am pretty sure that all of you at some point of life were grepping through log lines and, you know, looking around like what was going on. Here you just have it. You don't have to do anything else. It's just waiting for you. So this is cool, right? And as you can see, there are, you know, many projects, you know, in the observability area that try to fix this problem, to, you know, tackle the observability one way or the other, or the monitoring. And they do it like that, as I see it right now. For example, we have those three layers. First, we have the instrumentation layer. This is data creation. How do I create my data? There's like log4j libraries, or the libraries that create metrics or traces. The problem is that those libraries are different. Log4j doesn't create metrics, right? Or traces. It's only logging libraries. Then we have this collection. And we have another problem as well. Not only those protocols are different. Maybe they're the same. Maybe this is all going through HTTP. But even if that is true, then, you know, what is inside this HTTP, the payload is totally different, right? For logs and for metrics. You can send everything as JSON, okay? That is not a problem. The problem is that there is no standard. So we have this collection layer, and this for the collection, here we have FluentBeat, here we have Jaeger, and here we have, for example, OpenCensus, or we have Prometheus. And this is problematic, guys, right? Because those are not only have like different configuration, they are stored in different places, different release schedules. Try to do something with those data, try to manipulate them. It's totally different. You know, there are some plugins here that are not existent here. It's a mess, right? And then send those data to backend. Those backends, they just don't know about each other, anything, right? And this data is in different schema. And this is not a nice place to be. I mean, this creates real problems. And obviously, this is all like vendor provided. I mean, we can use FluentBeat, which is not vendor provided, it's open source. But still, if we use some vendor provided, for example, for traces, that is true. You know, from the instrumentation through the collector to the backend. The thing that I wanted to say here is that they are not interconnected with each other. And you know, to the rescue came two projects, and they started with tracing. They both started at Google. And they were mostly focused on tracing, and at some point they thought, okay, let's merge together. Let's create this OpenTelemetry. This is since May 2019. And, you know, like gather all this OpenTelemetry data in a way that the data creation, that the telemetry data are ubiquitous, right? They are not some, you know, locked in vendor specific thing anymore. Right, and I think that they are pretty successful about that. You can see that because, for example, the vendor support is very, very good. And you know, if you go here, just Google it. Just Google OpenTelemetry, and you see first. I mean, that first two links will be OpenTelemetry.io, probably, and some documentation. The rest of the links will be vendors: Datadog, Splunk, Sumo Logic, what have you. It's all there. Everybody would like to jump on this train. So we have another problem because we just add another thing in here, right? So I'm pretty sure that you are familiar with this. How do we prevent this from not happening? Because this would not be great. And obviously, OpenTelemetry is trying to be like one ring to rule them all, right? Let's you know, tackle this problem for everybody. Is it being successful? Let me show you. How is it different? Maybe it isn't, but I think it is. So we've seen that. This is OpenTelemetry on the right. Let's call it Observability 2.0. And how does it differ? First of all, OpenTelemetry provides this layer of the instrumentation libraries and the collector itself, right? It doesn't provide vendor, but what it does provide is the schema and protocol. So now imagine you have the data here for logs and traces in different vendors, but because they use the same schema, if your vendor, provide you this data, you can, query it with the API or something, you can correlate them. If your vendor doesn't do that, ask them to do, because you are paying them, right? So you should be able to ask for that. So even though there is no vendor, I think that is still a pretty powerful thing. And let's start here with the instrumentation. We no longer have like different libraries for logs, traces, and metrics. We have an SDK. This SDK is, goes from logs through metrics and traces, and it's self-contained. And not only there's like API specified, there is like actual implementation for of the libraries itself as well. Then we have a collector, and collector is another layer. We have one collector which is called OpenTelemetry collector. So we don't have to have another collector for logs, metrics, and traces. We have only one. And the beauty of it is that, for example, when we have processors to somehow change our data, right? We want to filter out something. The same processors can be applied to both logs and metrics, for example. If it makes sense, obviously, right? Because sometimes it doesn't, but sometimes it does. And we don't have to, switch between agents to make it happen. And then on this vendor, let me not repeat myself with this thing about querying data. But this is I think that this is a pretty interesting use case here. So that is work in progress. We are going into that. Let me show you how. But first, the vendor support, like I said, everybody is here. At least I think that all of those actually provide at least the protocol, OpenTelemetry protocol, to get the data. And I know that most of them provide some exporter in the collector. So you have a collector or telcol, you want to export your data to both Splunk and Datadog, you just use one collector. You just send this data, and it works. So this is very, very nice. Let me talk just a little bit what OpenTelemetry is actually. So it consists of specification, SDKs, and collector. And first, what is the specification? So like I said before, specification is API, SDK, some guidelines, semantic conventions, this very good thing, very big thing. Also specification, how to enhance the specification, and language independent interface types, so that it's not being developed for Java, for Python. It's language agnostic. For the within the specification, we have this resource semantic conventions. So I told you about that before, right? For example, if we add information about our operating system, we can be sure that this OS type will be there and it will have those values, right? And this will be consistent across logs, metrics, and traces. And this resource semantic conventions, they are very, very good for tracing at this moment. Not so good for metrics, I would say, and almost non-existent for logs, unfortunately. I mean, you can infer this information. You can think of it like if something exists for traces, it probably will be the same for logs. You cannot know that for sure, but here we are talking about the upstream, right? Nothing stops you from actually using those conventions yourself. For example, attaching those to logs. And we have this OTLP. That is a very nice thing because OTLP is a telemetry data protocol to send the data. Like I said before, we can, for example, send the data through HTTP, right? But what about the payload? Is it JSON? Is it just, straight, I don't know, HTML? That would be a funny thing to see. Here we have defined telemetry data protocol for logs, metrics, and traces. It is not easy, guys, I have to tell you. And the problem here, why it is not easy? Because the domain is not easy. If you want to tackle logs, metrics, and traces, and you want to have metadata on different layers, for example, you want to have metadata for hosts that your application run on, and for libraries that your that created your data, that has to be complicated. Unfortunately, it is not easy. But the thing is that it is being actually implemented by most of the vendors. So you can just use it, and you can send through HTTP or gRPC. You don't have to use JSON anymore. And let's talk just a little bit about this language SDKs. Language support is quite good, I would say. There are libraries for many languages at this point. And it's the same story like with metadata. Because OpenTelemetry started as a tracing project, this is very, very good for tracing, not as good for metrics. And for logs, this is actually a different story, because for logs, OpenTelemetry said that there are very good libraries for logs. There's like log4j, right? We don't have to re-implement them. They have appenders, so we will just create appenders. You still use log4j, but we will also use our appender, and that's the whole story. And it works. And when you want to create, the data using OpenTelemetry libraries, you can do it manually. You can just implement this SDK by hand and have it working, or you can use something that is called auto instrumentation. For example, for Java, you just have a Java agent. This is just a simple jar. You just run your Java with the jar, and it's all there. It's working because this jar knows how to tackle your libraries, for example, how to ingest itself into your Spring framework, and it can create traces out of this, just on the fly. You don't have to change anything, and this is very good. It's very good for Java at this point. That's how I know. I know because I've used that. I am not sure for other languages. I know that for PHP, for example, there is no auto instrumentation libraries, but there's a lot of people working on it. So I am pretty sure that if I were having this presentation in a year, the story will be totally different here. And now collector. I think that this will be pretty interesting for you guys as well. What is the OpenTelemetry collector? It's a binary that receives the data and sends them somewhere else. In the meantime, it can process them. So we have receivers to collect the data, like I want my data from this file, or I want this data. I want my data. I know that I have Apache, so I have Apache receiver. Give me all the metrics from the Apache, and add some metadata to this. Then we have processors. I want to drop, metrics from this host. I don't want them anymore, or I want to change something. I want to create new metric out of the metrics that I've created because my backend doesn't do that. Or I want to, aggregate my metrics because I don't want to pay my backend that much, right? Because I don't need this data. I don't need this granularity. You can do all that with the processors. And then the exporters, you just say, okay, I want to send to Prometheus and Sumo Logic and Datadog. And you just, add those three and you're good. All of that is used within the pipeline. So pipeline is actually receivers, processor, and exporters. You can have different. You can have many pipelines defined. You can have many receivers defined. It can be many receivers in one pipeline, and many pipelines can use the same receivers. It's very, very, very good configuration-wise. So here we have a example how it's working. Let's see. We have two pipelines here. This yellow one and the green one. So the yellow one listens on the OTLP, then sends the data through the batch processors and attributes. For example, here we add some metadata, and then it sends to Jaeger. So I can only infer this information that this is about traces because it sends to Jaeger. And the second one, again, uses the same OTLP receiver, then goes through batch and filter, so it filters out some data, and then sends to both Prometheus and OTLP. That means that this is metrics. That's the whole idea, what you're doing here. And let me show you examples, like three very, very short examples. Here we have the host metrics receiver, for example. How to, what we can do with the host metrics receiver when we, run it, we can get metrics from my host, like CPU, memory, how long it works, about the file system usage, what have you. Then we can process the data. Here, for example, with the resource detection processor, we can add information from which host this data originates. This came from my host apache.localhost, for example, or something like that, right? And then we have the OTLP exporter, which just sends the data to some exporter. Like I have an endpoint hotelcall2. By the way, this 34317, this is a port that is officially recognized by IANA. So you can just use it and be sure that it should be OTLP, there. So that's a nice thing. And here we have how this configuration looks in total. We have defined first receivers that we want to script memory, processors. Here is how you do if you want to have like multiple resource detection stanzas, like I want to have like 2 or 3, you can name them. This one is named detect hostname, resource detection / detect hostname. It will detect the hostname, and then I want to send to the OTLP endpoint, and then I wrap it around in the pipeline here. That's it. You just run it, and it works. And now the distros, because this is just a little bit fuzzy, I'd say. So we have a couple of distros. First of all, we have core distribution. This one is called hotelcall. And if you use this one, it actually cannot do much, surprisingly. I mean, if I were, the creators of this, I would do it different way, but it's not like that. If you use just hotelcall, it can listen on OTLP and sends the OTLP. It has I think 2 processors or something, like very, very small binary, very small capabilities, not that usable for me. But upstream creates also another one, and they call it contrib. This one is batteries included one. It has all the wheels and bells and whistles from vendors. For like, if you want to send data to some vendors, you have the exporters added here, right, to this contrib distribution. And this is the one that I would use, and it is called hotelcall or contrib. And if you ask me, I would do it the other way around. I would call this one just hotelcall and this one just, I don't know, like hotelcall stripped or something. But it is what it is. And we have another thing, which is custom distributions. So we have like our Sumo Logic distribution, and we have AWS distribution and some other distributions. What it is, those are not forks. Those are distributions in a way. You can think of it as you think of Linux distribution. You just take this binary, that binary, and just put them together, right? So these are this kind of distributions. And for example, we create our own distribution because we want this agent to show up on a UI. So it has to have some other capabilities that are not baked into the upstream one, right? Because the whole community is not interested in that, only ourselves. So we just bundle it, and we just say, okay, so this is our distribution, we build it from this package, we support this set of packages, and we're done. And I think that this is pretty okay to use those. For example, if you use AWS, they have their own distribution called ADOT, and they support it. So I think it's fair to just use it. But it doesn't differ that much from the contrib one, because they just, if there are some patches, they apply those. But that doesn't happen most of the time. Okay, we can talk just a little bit. Let me talk about the community, what we are dealing with. So the community is quite good. If you would like to contribute to this project, it's very easy. If you'd like to get some information about this project, it's easy as well. There is org at GitHub. There are tons of mailing lists, Slack channel, and GitHub discussions. All of this is used. There is also open calendar and community page. There is tons of information on the official documentation. And there are the special interest groups meetings. So if you are, for example, interested in collector, something doesn't work for you, you can drop a question on the Slack channel. Then people might tell you okay, let's go to the SIG meeting and just discuss this face to face, you can go to the community SIG. They are open, they have minutes, they are actually there on the YouTube channel. You can watch the past ones, so they have a very, very good hygiene here. And this community is very friendly, so if you are interested, I urge you to just go there, because it's a pretty good project to be involved with. If you go to the GitHub repository, you can see that there's a lot of traction in there. Like, there's a lot of work, like I said before, with these instrumentation libraries. This is ongoing. I know for a fact that like 2 months ago there was no Go instrumentation, for example. Now it is there, this auto instrumentation. Or for the PHP, it's happening right now, because, for example, our company is investing in that as well. So this will happen, and it's happening across all of those repositories. Also, if you can look at this chart, this is Cloud Native Computing Foundation information about the projects. So you can see, if you can see here, OpenTelemetry and Kubernetes. I don't know how good visible is that, but there are Kubernetes, and OpenTelemetry is the second. So OpenTelemetry has a lot of traction right now, which is good, because I think that we as users will benefit from that. Yeah, so as a word of ending, if you'd like to contribute, just go there to this open source community, and if you're interested, you totally should do that. Here, guys, you have some links. I told you about this OpenTelemetry.io, this documentation. If you'd like to have some hands-on experience, we also created this OpenTelemetry workshop. This is for both libraries and the collector itself. If you'd like to play around, you can just do some exercises and get some knowledge how to work with this OpenTelemetry thing. And actually, that concludes my presentation.